Hi, it's Andriy, and I welcome you to chapter 1.3, which is decision-making operators. Today we learn more about these decision-making operators. These operators are not really unique for Kotlin. Most of the programming languages have this concept. So what's this all about? In order to explain things better, I really like to give some real-life examples. And this make it more understandable, so to say. Well, think about the program like in a small written story. So today, let's imagine a weekend. And imagine that you have two options. First option is to go for a hike to this nice mountainish landscape, or to stay home and play PlayStation. So how would you choose the type of activity? So for me personally, weather is important. And let's try to code this situation in Kotlin. Let's open our Kotlin playground. And here we would need two outputs. So first output, which will represent the fact that we are going for a hike. So let's write here, go hiking. And the second output will be play PlayStation. So don't forget to write here println to have nice shiny output. And let's check what do we have here. So when we run our program, we see the output result, go hiking and play PlayStation. Now we should decide which output we need to show to the user, depending on something. Before writing decision-making operators, we need to specify the condition first. So as you already know, we can create a variable, the final one, which will be is good weather. So this simple variable represents the state of the weather. Is it good or not? So think about the type which we need to choose and stop the video and create the final variable. Okay, we are back, and in case if you have any troubles here, I will do it right now. So we have variable is a good weather. It should be Boolean. And let's make it true. So something like this. Now we can create our decision-making operator. In order to do this, we need to use keyword if. And as you can see, it's orange, which means that compiler can recognize this word as an operator. And the syntax is following. So you need to put parentheses, and in parentheses we need to specify the condition. In our case, condition is good weather variable. Let's write it down. Okay, and the second part of this decision-making operator is curly braces. So we open our curly braces, and as you can see, this is a nice feature of Kotlin Playground and any other IDE itself, that it adds the second curly brace. So opening curly brace and closing curly brace. Well, our decision-making operator is ready. And these curly braces, they indicate the code which will be executed only in case if is good weather is true. I think it's pretty obvious. So if condition, then we execute the code. Let's put our output, which represents the hiking, into the curly braces. Yeah. Now let's run our program. As you can see, nothing was changed, but this is something obvious. Is good weather is true, so our code in curly braces is executing, and then After it's executed, we execute the leftover, which is play PlayStation. In order to do the decision making, we need to add else keyword. So if our condition is false and this code is not executed, we need to execute else block, this one. Now we can try to run our program again. Now it looks better. As you can see, it shows only go hiking here. Well, let's assume that weather is not good. We change it to false and try to run our code again. And obviously else block is executed here. Pretty straightforward. But in real life, everything could be a little bit more complicated. This is, as I said, super straightforward example. But what if we have more conditions to decide? Good weather is not enough. Usually people, they have mood, and we can also represent it in our Kotlin playground. Let's create a variable mood. And I would represent it as an integer from 0 to 100, where 0 is the worst mood ever you could have, and 100 is like the best, happiest mood in the universe. So let's be optimistic and put our mood to 100. And now we can do our decision-making operator more complex. Now we can combine the condition. In order to do this, in most of the programming languages, there are logical operators. Here they are. First one is logical AND, and the second one logical OR. And these logical operators, they compare two Boolean variables or expressions and make the result. How it looks in real life. Let's imagine the weather is good, but mood also should be good in order to go hiking. That's why we use logical AND. And from the math, we know more or less operators. It's the same in programming. And we assume that mood should be more than 50. Only in this case we go for hiking. Let's try to execute this. Yeah, we still play PlayStation as weather is not good. Let's change it to good weather. And yeah, we can go for hike. Well, if both Boolean variables or expressions are true here, first one and the second one, then this means that the whole expression is true as well. And first block of code in parentheses, in curly braces, will be executed. What about OR? Let's have an example with OR. But for this example, I will put the mood to 40. So we are not in a good mood today. And let's see what's gonna happen. So good weather is true, but mood is less than 50. And we still go hiking. So in order to make the whole expression to be true, only one of those two expressions needs to be true. Now it's time to execute our program. We press run. And here is the result, which is go hiking. Why it happens? Because is good weather is true. Even if we have mood less than 50, still, because we use the logical OR, this part is executed, which is go hiking. After we learned about logical AND and logical OR, we can go further and learn about cases. Now we have only two cases, which is if and else. First one is go hiking, and second one is play PlayStation. What if it's not enough to describe our weekend plans, and we need more cases, more activities, let's say. In this scenario, we would need to use else if. Else if, and here we need the same as for if, the expression, the Boolean expression, and here is the activity which we are going to plan. Let's say it's go shopping. And when it will be executed, I would check on the mood. So if mood, for instance, is more than 10 and in the same time less than 50, then we go shopping. Well, looks good. Now we can execute our program. Well, and it still says that it's go hiking. The question would be why we still don't receive go shopping. Yeah, it's because our good weather is still true. So even if this one is true as well, only the first if will be executed. As soon as the whole expression meets the true, here or here, then this branch or this scenario will be executed. Let's change is good weather to false and try to rerun the program. Now we can see that it's go shopping. For if and else, we can introduce as much else if as we want. So it could be endless amount of else ifs, but think about this way. If you have too many else ifs, then this means that probably your program architecture is not good enough. Finally, I want to show you some useful features which Kotlin has for his ifs or decision-making operator if. In general, this whole expression is a variable. I mean, it could be initialized as variable. I will show it how it works. So let's call it weekend activity. We can do this and remove println everywhere. And we can do println weekend activity. Yeah. Let's try to execute our program. Well, basically nothing was changed. It was just minor refactoring or making our code better. So in Kotlin, every if operator returns the type in this curly braces. In our case, depending on the Boolean expressions, this if, the whole if with else's, returns the string, which we can print afterwards. Isn't that cool? I mean, I'm not sure about other languages, but in Java, there is no such option. Another place I see which we can improve here is the second Boolean expression here. In Kotlin, there is an operator called in, which is used for ranges. And if our mood is in range from 10 to 50, so this is the syntax, go shopping will be executed. As I said before, nothing changed, but our code looks fancier. We don't need logical AND. We just check if our mood is in some specific range. As I said, in Kotlin there are lots of cool syntax sugar features which makes your code readable, understandable, and from time to time you will learn new things and you will improve your code constantly. This is like long-running process. So be curious about new features, be curious about new versions of Kotlin, and stay tuned for new Kotlin lessons on this channel. Well, if is not the only decision-making operator in Kotlin. There is another one, and it's called when. If you came from another programming language, you might heard about switch or even use it. So there is no switch in Kotlin, there is a when operator, and in my opinion when is a little bit better, so it's like an upgraded version of switch. About the use cases, yeah, it's used in the pretty similar use cases like if, but to be quite honest, I like the syntax of when a little bit more. So let's start coding. In order to compare these two decision-making operators, if and when, I will keep if implementation, and you can basically see the difference right away. Let's start. So the syntax is following. You need to write when, and here you have a couple of ways. The first way, you open parentheses, and in parentheses you need to specify which variable are you going to compare. I would say that for the first look we will use the mood variable, which we already have, and here in the curly braces we implement the body of the when operator. And here we basically specify the cases. So first case here is go hiking. And as we're comparing mood, we are not comparing is good weather for now, just for now. So we need to write the first case. And first case will be that our mood is in range from 50 to 100. So this is a Boolean expression. And then syntax is following. You need to place this arrow, which is lambda operator, and right here, go hiking. Important to mention that range operator works a little bit different. So range operator works, it includes this border variables. So if you really want to have the same behavior for mood as for if operator, you need to place 51 here. So from 51 to 100 we go hiking. The next one is in range from 10 to 50. It's basically the same. We go shopping. And last but not least, else we play PlayStation. So as you can see, we have also three cases, and the same as for if, we can equalize it to a variable. Let's call it when weekend activity, which is equal to this expression, and we can print this when weekend activity. let's check what do we have here. Unresolved, this one goes here, yeah. So as you can see, the same output for weekend activity and for when weekend activity, but still those expressions, they are not equal, because here we have is good weather and here we only compare mood. And this is what I mentioned before, is about upgraded version of switch. So in switch operator, usually you compare one single variable to some options, like options do you have, ranges or exact number or anything else, but you compare the single variable or expression. For Kotlin when, you can basically remove this, put mood here, and use it this in the same way as in if. So we copy is good weather, we have logical OR. So yeah, let's change our good weather to true. And let's execute our program. Yeah, it's the same output, go hiking. So now our both expressions look the same. For when, you have two options of syntax: to compare one variable or just compare any Boolean expression here and here. Now it's called challenge time. Let's remove our current implementation. And here is our task. So the task is to show some messages for car speed. First, we need to create a variable which represents a car speed. We need to show error message if car speed is less than 0. Because the speed obviously shouldn't be 0 and it's not really possible. Show the message that the car has stopped when the speed is equal to 0. Also, we show the message go faster when for speed less than 50, and the normal speed for speed 50. And finally, we should show the message be careful for speed more than 50. The hint is that we have to use if or when operators. So please stop the video here and try to implement this task on your own. Good luck. Okay, if you have problems with this task, let's do it together. So first thing first, we need to create a variable which represents the speed of the car. We call it speed, and let's make speed 40. We can use if or when. Personally, I prefer when, as we're going to compare only one variable, which is speed. When is the perfect choice for this. But obviously, you can use if. This is not a big deal. So we compare speed. In the first case, if speed is -1, we have to show the message error. Speed can't be less than 0. Next case, if speed is equal to 0, we show that car has stopped. Next one, if speed is less than 50, we need to show the message that you should go faster. So speed is in range from 1 to 50. We say go faster. Next one. If we are at 50 speed, we show the message normal speed. And for the last case, we can just use else, as we don't have any other cases. And if our speed is not -1, 0, or in this range, or doesn't equal 50, then this means that else will be executed, which is more than 50 kilometers per hour. And here we write be careful. One mistake I see here, I made one mistake. As I mentioned before, range works with this border values, so this has to be 49, from 1 to 49 including. Now, as I showed you before, we can equalize this to the variable. In our case, it's message string variable, and we can now print it to the console. Here we go. Our speed is 40, so we assume that it should show go faster message. Let's press run. Yeah, as you can see, it's go faster. Let's change it to 50. It's normal speed. Let's change it to 150. And we can see be careful message. I hope you like this lesson. I hope you understand what if and when operators are doing, and this is something which is pretty useful in Android development. So here we're just printing some dummy messages, but these things are really widely used when you write the real Android application. For instance, you need to show some information to user on the screen, and if there is no internet, you show one information. If there is internet, you show another. If you're able to load some list of data, you show it. If the list of data, for instance, is empty, you show the empty message on the screen. Obviously, those things like when and if, they are commonly used, and this is something you will need. In case if you missed something, I would recommend to watch this lesson again and try everything again on your own. So see you in the next lesson.